A railway platform is an area alongside a railway track providing convenient access to trains. Almost all stations have some form of platform, with larger stations having multiple platforms. A platform gap is the space between a train car and the edge of the station platform, often created by geometric constraints, historic legacies, or use of partially compatible equipment. Platform gap fillers are movable platform edge extension at subway or railway stations where the curvature of the platform creates a significant gap between the platform and subway or train car door. Mechanical platform edge extensions, known as platform gap fillers, may be used to bridge the gap between platform and vehicle. Mechanical gap fillers, MGFs, shall be able to fill up the gap between platform and the train door for preventing passengers falling into the platform gap. The MGF shall be a self-sustainable modular design which enables installation work to be completed individually in the operating railway during the non-traffic hours at night time. The installation work at the platform edge would require specific booking of track adjacents on designated nights. The partly installed MGF system platform shall be self-contained and shall cause any disruption or inconvenience to the normal railway operation or tripping hazard to passengers. The MGF shall be able to operate independently even without the completion of the whole installation of MGF along the platform. All materials, details, equipment, and workmanship which have no specific standard specified in contract shall comply with the relevant EN or BS standards for the equipment. Electrical or electronic devices or enclosure of electrical devices shall have a degree of protection not less than IP65 in accordance with IEC 60529 or EN 60529. The contractor shall comply with all local regulations and satisfy the requirements from owner. The safety integrity level of the system shall be strictly in accordance with EN 50129. The system design and development shall comply with the requirements as stipulated in EN 50129. The material of the system design and development shall not be a cause of flame to spread and emit toxic gases in case of fire. All material shall be non-combustible. The system shall always maintain a safety state in any circumstances, including startup and shutdown. Failure of single components or subsystem of the system shall not result in spurious movement of MGF. The design life of the system and the major components shall be at least 20 years with the minimum maintenance. Styling and the architectural design decisions shall be based on both functionality and the needs of passengers. The MGFs themselves shall be elegant and integrated with the platform structure. Details shall be uncluttered, straightforward, and rational. Fresh finishes with concealed fixings shall be used wherever possible. The MGF shall be fabricated with suitable material which can minimize the weight of MGF while it can withstand all required loadings. The mechanical gap filler can be folded type. The surface of the MGF shall be heavy-duty, wear-resistant, and finished with the anti-skipping pattern. The maximum gap to be filled by the mechanical gap filler is approximately 300 millimeter. The filler plate and the supporting linkage shall support the weight of passengers, passenger on wheelchair, and as well as luggage carried by a passenger. The filler plate shall be flush with the platform edge surface after the filler plate is raised. The operation of mechanical gap filler shall not cause any damaging contact with the train throughout its full swing or stroke. The setting of the MGF shall be in line with the train doors at normal stopping position. Variation on the train length shall be considered when deciding the MGF length. The preliminary sequence of the actions are listed as follows: train approaches platform, train stops, MGFs are raised if the stopping accuracy is within the set tolerance. After the MGFs are fully raised, a confirmation signal is sent back to the signaling system. Train doors open, passenger boarding and arriving. Train doors close. After the train doors are fully closed, a confirmation signal is sent back to the MGF system via signaling system. MGFs lowered, visual audible warning may be given. After the MGFs are fully lowered, the confirmation signal will be sent to the signaling system. The status of MGF shall be displayed in the MGF status trackside indicator. Train departs. The interface signals with the signaling system employed in the above operation sequence shall be battery signals with double cut circuit design. Voltage-free dry contacts and relay complying with BR930 or equivalent shall be adopted. The contractor shall coordinate with the signaling system to develop detailed operation sequence and the requirements of interfacing signals. Train operated in ATO, automatic train operation, or ATP, automatic train protection mode shall have control on MGF system via signaling system. Train stopping accuracies in different mode of operation is plus minus 500 millimeter. The normal frequency for the operation of mechanical gap filler shall be one cycle operated return per 2 minutes, or the highest frequency that the signal system can allow during the operation hour. The contractor shall note that the actual number of operations will be higher than the normal frequency due to recycling of train doors due to operational reasons. The response time, which comes from receive or valid command from the signaling system to MGFs, fully raising from its normal position to operational position, shall not be more than 1.5 seconds. The MGF shall return from fully operational position to its normal position with 1.5 seconds after receiving valid command from signaling system. The above response times shall include the response times for sending confirmation signals to signaling system. MGF unit shall be at platform edge and aligned with train door. It shall be a self-contained unit which includes control equipment and the driving mechanism. The casing of the unit shall prevent ingress of rainwater. Drain holes shall be provided to prevent flooding within the unit in case of failure of sealing. Casing of MGF unit shall be made of a suitable material which can take up all structural loading throughout the design life with minimal maintenance. Surface of the MGF unit shall flush with the platform edge structure, heavy-duty, wear-resistant, and finished with anti-slipping pattern and material. The contractor shall ensure that the interface with existing platform edge shall be durable and not introduce tripping hazard. Structural interface with civil provisions shall be simple and allow quick installation during non-traffic hours. The partly installed components on the platform shall affect the boarding and the lighting of passengers during traffic hours or induce any tripping hazard. Installation method shall produce low noise level which complies with the relevant regulations. Electric drive shall be adapted for the driving mechanism. Design of the driving mechanism shall standardize the dimensions of filler plates for the MGF units with different strokes. Distance for the filler to travel for filling up the gap, hence to ensure interchangeability of filler plates. The MGF control unit shall be the controller of individual MGF unit and interface with the MGF interface unit. All local operations and the controls shall be performed and controlled by the MCU housed in the MGF unit. Filler plate is a movable plate which fills up the platform gap for boarding and the lighting of passengers when it is in operational position. It shall return to its normal position by folding down below the platform edge and allow train departure after platform duty. The outer edge of the filler plate shall be made of rubber fingers to allow maximum intrusion of the KE. The contractor shall standardize the size of filler plates for different MGF units. At each MGF unit, there shall be an array of indication lights which will illuminate when the MGF is not in folded down position. The indicator light shall be of LED cluster type and installed in the position where it is easily observed by the staff at platform supervisory booth. The MIU MGF interface unit is the control cabinet in which the signaling system and the MGF interfaces are connected and at which control signals are marshaled and transmitted to and from individual MGF unit and panel. The MIU will serve as the central communication of MGF system with other systems externally or internally. The arrangement will centralize all the signal flows in and out of the MGF system, which will be more convenient for the maintenance staff to carry out primary check of any fault reported from the MGF and locate the root cause. The MIU shall provide visual display of MGF operational statuses and alarms. All input and output signals, events and alarms shall be stored in the MIU. The MIU may be located at platform and shall have a degree of protection of IP65. MSP MGF status panel will be located at the strategic location including SCR and PSB. MSP shall display operational statuses and alarms of the MGF system. Individual status of the MGF shall be displayed on the MSP. The MSP has visual display and audible alarm, which alert the platform staff to any abnormal conditions of the MGF system. A mute button for staff to acknowledge the alarm is provided on the MSP. The buzzer shall be programmable to be muted automatically within a preset period or disabled. Major alarms and the statuses signals shall be connected with the hard wires from MIU to MSP. MLP MGF local control panel will be provided at head wall and tail wall of each platform which has the MGF system installed. The MLP shall provide indication of the system status and provide platform level control of the MGF system. A bypass feature interlock override shall be provided to bypass the departure confirmation signal to signaling system if the signal is not confirmed, and for operational reasons it is required to bypass the signal. The MLP shall have a degree of protection of IP65. MGF status track side indicator made up of LED arrays shall be provided at each end of each platform to show the clear and true indication of MGF status to the driver in train cab. The indicator shall illuminate only when all MGFs of the respective platform are in normal positions. MGF power supply equipment (PSE) shall be fed from station power supply and regulate the power for the MGF system. PSE shall consist of power supply units of control power and drive power to MGF units. PSE shall have the capability to maintain the supply of control power for 30 minutes and drive power of 30 operations in 30 minutes in case of a failure of a station supply. All supply voltages shall be DC and shall not exceed 110 VDC. All major control and monitoring equipment and subsystems shall be had from a control power supply. The PSE may be located at platform and shall have a degree of protection of IP65. The contractor shall supply and install cable containment for the MGF system. The monitoring system shall provide indications of the statuses of the MGF system. The statuses of monitoring points will be sent to or displayed at MIU, MLP, and MSP. A list of alarms and statuses to be recorded in MIU and displayed in MIU and MSP shall be submitted for review. Detection of object or passenger or filler plate shall be provided to prevent lowering of filler plates when object is sitting on or passenger is standing on the filler plate. This shall be a fail-safe detection. Positive output of this object detection device shall inhibit the movement of the filler plate. The object detection shall have sufficient coverage of the filler plate. Small objects such as ladies' high heel and lightweight objects shall be detected by the object detection system. Alarm shall be sent to the MSP and the local warning shall be provided on the detection of objects after train doors are closed. The contractor shall propose different detection methods for review and consideration, which may include pressure mat, load cell, a limit switch, infrared scanner, image recognition, ultrasound sensor, or their combination. The selection of object detection shall consider the adverse outdoor trackside environment and the interference due to exposure to direct sunlight and a heavy rain. MGF shall provide the obstacle detection function. It shall detect the obstacle while lifting and loading. It shall recycle for several times if an obstacle present and raise alarm if the MGF fails to move the required position after several attempts. The obstacle detection shall also prevent trapping of passenger shoe or other objects. It should also limit the force and the energy of a moving filling plate to prevent the passenger from injury. The contractor shall propose a suitable method to prevent and detect the passenger falling the platform gap between two adjacent MGFs where the gap is in excess of 250 millimeters. At each MGF unit, a local manual selector switch, which is easily accessible at platform, shall be provided to set a particular MGF in the automatic, isolated, or maintenance mode. When MGF is in automatic mode, the MGF shall be under control and monitoring of MIU. When MGF is in isolated mode, the MGF shall not be controlled by the MIU, but the status of the MGF shall be under the monitoring of MIU, and the status of the isolated MGF shall include it in the departure confirmation signal, the signal system only. The drive power to the isolated MGF shall be removed. When an MGF is in maintenance mode, the MGF shall be still under the status monitoring of the MIU and the signaling system. The MGF shall be able to be controlled by the local control buttons housed in the MGF unit. The selector switch and the local control button shall be properly located and covered to prohibit access or tamper by passengers. A sealed switch or high security switch shall be used to bypass the interlock with the signaling system in case of the retracted status monitoring or detection sensor failure. In case our MGF unit does not function normally, visual and audible warning signals shall be given to the waiting passengers on the platform to remind the passengers of normality. The audio alert shall be audible to the passenger near to the problematic doorway. Mechanism for emergency operation shall be available for staff to manually operate the MGF unit without access from trackside. This emergency loading mechanism shall be fail-safe, easy to operate, and efficient to avoid affecting train traffic. The mechanism shall be able to reinstate the filler plate in normal position within 10 seconds with a clear physical indication of the locked position of the MGF. MGF unit shall be fixed to the platform structure. Fixing details shall be coordinated with civil works contractor. The interface design shall allow minimal site installation works and consider the tight installation schedule. The contractor shall submit design to show how the MGF is fixed to the existing platform structure. MGF shall be designed and constructed to withstand loads and combination loads conditions. No movement or deflection of any parts of the MGF to trackside is allowed under all different load conditions. The passenger load is 3 kN per square meter. The MGF, including filler plate, shall be designed to operate under this loading throughout the design life of the MGF. The filler plate shall be designed to withstand a load of 2.5 kN applied along the leading edge of the filler plate. Any part of the filler plate shall not deflect for more than 5 millimeters and shall not deform permanently if the load is increased to 3.5 kN. The filler plate shall restore to its offload position after removing the loads. The filler plate shall maintain a fully operational position even at a horizontal force of 1 kN applied from trackside during passenger boarding. Earthquake force shall be deemed to be included if structures are designed to additionally resist the loads and forces created by an ultimate horizontal or vertical acceleration of 0.07 gram. The design of the MGF shall be fail-safe. Failure of any mechanical device that raises the MGF, example, motors and gears, or that enables it to stay in position, for example, a brake or a lock, shall cause any hazard to passengers. Duplicated position sensors shall be provided to achieve high availability and to provide a clear and true indication of the status of the MGF. Failure of one of the sensors shall prompt the maintenance alert. When there is a drive power failure, the filler plate in motion shall be controlled to react in a means that shall cause any hazards to both trains and passengers. The MGF shall be equipped with mechanical lock or brake to maintain the MGF at normal or operational position in case of power failure. In the event of a train hitting the filler plate for whatever reasons, the filler plate shall either be reinstated in its normal position or detached from its supporting structure without damaging the train body and MGF or causing passengers to get hurt at platform and on board of train. The design shall also safeguard the passengers at platform. The contractor shall submit a detailed design and calculation and conduct type test for demonstrating the compliance. Warning strip or hatching pattern shall be provided at the edge of the MGF to prevent the passenger from falling to gap. The MGF shall be designed so that passengers can easily distinguish the MGF is at the normal position or the operational position. The design and the construction of the MGF system shall enable regular and reliable operation to be achieved for the system design life. Quick recovery mechanism of MGF shall be provided. Any failure within the MGF shall be rectified or bypassed such that train service delay due to MGF failure shall not exceed 8 minutes. The mean cycle speed in failures, MCBF, criterion is as not to exceed 1 failure per 300,000 cycles. The service failure rate of MGF shall not exceed 1 failure per 2 million cycles. The service failure is the failure as a result in train service delay of more than 3 minutes but less than 8 minutes. The MCBF is measured in system-wide MGF installation. A cycle will be one complete operation cycle of MGF unit. A good system design, maintenance procedures, and suitable spares holdings are necessary to ensure the availability requirements of the MGF system. The availability of the system shall achieve 99.99% or better. The MGF system shall be designed and constructed to maximize the maintainability of the system. All components, sub-assemblies, or major assemblies shall be capable of being maintained or completely replaced within 3 hours or less during non-traffic hours. It shall include the time required to remove the components, sub-assemblies, or major assemblies from the MGF system for the purpose of replacement of worn components or the rectification of faults. All these works shall be done entirely at the platform.